Another type of power plant that bears some resemblance to a traditional power plant is a geothermal power plant. And we'll look at some of the similarities and differences in this video. Now, first of all, what is geothermal energy, or what is geothermal power? Underneath the Earth's surface, we have something called a geothermal reserve. And the simplest way to think of this is that it's a huge amount of heat energy stored below the Earth's surface. If we think of things such as volcanic eruptions, that's an example of some of that geothermal reserve escaping to the surface. We also see similar things in natural hot springs. So sometimes that heat energy, or that geothermal reserve, finds a way to escape to the surface. Now, when we use geothermal energy, we're actually tapping into that thermal reserve. Now, not every location is suitable for a geothermal power plant because those geothermal reserves sit at different depths in different locations. And in the UK, the best geothermal reserves, or the geothermal reserves that are closest to the surface, are actually in the south of England. So how does a geothermal power plant work? Well, in this case, we actually have two working fluids. The first working fluid is water. And we can see on our diagram here that cooled water is injected below the Earth's surface through an injection well. Now, that cold water is going to travel down into the geothermal reserve where it's going to become heated. And what we're going to end up with is hot water, or steam, exiting through the production well. So we have our injection well where the water enters, and we have the production well where the water or steam exits. So now our water has absorbed energy from the geothermal reserve. The problem is that water or steam isn't going to have sufficient energy or enthalpy in order to drive a turbine. So instead we use something called a binary power plant. And in a binary power plant, the hot water is going to transfer its energy to a different working fluid. And these working fluids are typically hydrocarbon gases such as butane or pentane. Now, the reason we can use those gases is because they boil and evaporate at much lower temperatures. So our hot water is going to transfer heat energy to our working fluid. Our working fluid is going to evaporate and become a high pressure gas, and that high pressure gas is going to be expanded through a turbine. So the principle of the turbine is exactly the same. We're taking a high pressure gas, we're expanding it through a turbine. That causes the turbine to rotate as enthalpy is lost from the working fluid, and that rotation is used to drive our generator and produce our electricity into the grid. So we can see a number of different benefits here. First of all, the energy production is going to be constant. Unlike, say, wind energy, where the energy production can be unpredictable, geothermal power or geothermal energy is going to provide a constant source of energy. We can also see that there's no pollutants or contaminants being released to the environment because our working fluid here is part of a closed system. It's the same fluid moving around the system. So providing there's a geothermal reserve, geothermal power can be an effective way of producing sustainable energy.